So today we'll see an implementation of the slowly changing dimension to a Datastage job. So again, there are various ways to do the same thing. So we'll see the most basic concept that we use to implement a slowly changing dimension type 2. So a slowly changing dimension type 2 is basically what is shown in this diagram. So whatever is the current record, so there are two indicators mostly in a type 2 dimension, the start date and the end date. And the current record is indicated by the maximum end date. So the maximum end date in most of the cases would be defined as 31st December 9999. That would be the max end date. And by looking at the max end date, we can recognize that this is the latest record for that business key existing in that dimension table. So type 2 is basically the one dimension that will retain the history. So if a new record comes in for the same business key, so in this case, the business key is the source product ID, and there is a change in the product description. So earlier it was 10-inch glued box, and they have updated it to 10-inch pasted box. So how type 2 will work is basically the record that already existed in the dimension table will be end dated, and a new record will be inserted in the same dimension table with the start date, which can be the transaction date, the load date, or however the business tool is defined, and the end date will become maximum for that record, for the newly inserted record, to define that that is the latest record existing in the dimension table. So the start date of the latest record becomes the end date of the previous record. So this is normally how type 2 dimensions will be structured in the data model. Sometimes there is another column as well, which is the current indicator column. So for the current record, they set it to Y. For all the other records, it is set to false or no. So this is basically what we'll see. So mostly they'll have the start date and the end date columns because that defines the period in which that record was current for that particular business key. So what we'll try to implement today is we have some dimension called employee. We have some data in that. The employee number will be a business key. We have some attributes related to the employee. We have a band and we have a department ID that would be a changing column. So the attributes that might change. And again, we have these date fields which indicate the period for which that record was current. So the start date and the end date. And then we have a surrogate key. So for every record in the dimension table needs to be identified uniquely. So technically, we need to create a surrogate key that will identify each record in the dimension table with a unique ID generated. So the business key might repeat, but the surrogate key will always be unique. And the data that we'll be getting for each batch load would be a kind of incremental load. So every day we'll be getting all the records that have been updated from the source end. So mostly the criteria would be based on the transaction date or the update date from the source end, whatever is the column that we are getting. So for us, for this example, we'll use the transaction date as the date to identify the current record. And we'll get all these columns. We have the same attributes coming in from the source data, the employee number, the other attributes. There's a department that needs to be associated with a department ID, and then there is the hire date and the band. So the only two attributes we are considering might change is the department and the band for that employee. So now if we want to implement this in Datastage, one second.
Shivani, are you there?
Yeah, one second. I'm just
Sorry.
sizing my.
Just went quiet, sorry.
Yeah. Okay. So the SCD2, as we are going to try to implement through a Datastage job. So this is our job. And one second, this is kind of fun. So this is a job that we are going to design for the SCD2, and we are not able to view the palette, so we can just go to the view category. We need to select the palette and we'll be able to see it. So I've already defined the sequential files which we are going to read as a sources. Now in most of the cases, because there will be a proper data warehouse, there won't be sequential files or data sets that we'll be reading from. We'll be reading from actual database tables. So a common concept that is followed is after every dimension table is loaded, it is unloaded into a data set. So all the data from the dimension table is extracted and put into a data set or a sequential file, and that sequential file is then used across multiple jobs, because there will be various facts that would be designed which would be using the same dimensions. So dimensions are mostly conform dimensions, so they are commonly used across facts. So instead of every time going and querying the database, once the dimension load is completed for the batch flow, the dimension is all the data from the dimension is extracted and kept into a sequential file or a data set, which is known as an unload data set. So that is the first step that is done when we are actually loading a data warehouse. So we have some data, the dimension data in a data set, unload data set or a sequential file. We'll have incremental data that comes in. So the first step that we need to perform is to check whether this data that we are getting from the source, did we already have the same business key existing in the dimension table. So what we'll do is we'll go to the processing category and we'll pull a join stage. So I have a join stage. And we'll join based on the business key that we have. So the business key in this case for us is the employee number column. So we'll join based on the employee number, and this will not be an inner join because I want all the records to be taken from my incremental data link or the source data link. So I need to define it as a left outer join, and I need to check my link ordering. So my incremental data is the left link, so that's okay. Then I need to go to the input tab. I need to define the partitioning. For a join, it is a must to have the data, input data partitioned and sorted on the key on which we are going to perform the join. So I need to partition and sort the data on the employee number column for both the input links. So again, I'll select the other input link and again partition and sort the data. So now we have defined a join. We are basically joining on the same business key to check whether the record with the same business key already exists in the dimension table or it does not exist. So if it already exists, then we'll get a match. If it does not exist, then whatever attribute we pull from the dimension will have a value of null in it. So the only attribute I'm interested in at this moment is the employee ID, the surrogate ID that was generated for that record, which already exists for the employee number. So I'll go to the output tab and I'll pull all the columns from my left link. And I want the employee ID column from my right link. I don't need the start date. I don't need all the other details. I don't need the department ID and date, so I can just remove those columns. So I need all the source attribute columns that are coming for my incremental data, and I want the employee ID for the latest record for the same business key, which is employee number in this case, that exists in the dimension. Now again, we have simply connected this to the join stage, but what will happen in real case scenario is that a dimension will already have a lot of history records for the same employee number. So the one that we just want to check the latest record. So we'll put a filter where end date is equal to maximum date, and we'll just extract the latest records from the employee dimension table for a unique employee number. and we want the employee ID of that latest record. Employee ID is the surrogate key in my dimension table. Why do I need that employee ID from that dimension table for a record that already exists? I need the employee ID to be able to update the end date of that latest record, because now I've got a new record coming in from my source for the same employee number. That means some attributes have been updated. So I would need to insert a new record with the new attribute values, and the already existing history record needs to be end dated. So that's why I need the employee ID of that record to identify which record I need to update for end dating it. So from here, I've pulled the employee ID from my dimension records which already existed for that employee number, and I have all the other records coming in from my source. Once I have the employee ID, I need to do some basic transformation. From the source, I will not get any ID columns. So if any lookups need to be done, we need to do them. So we use a lookup stage because I'm getting department name. So I need to map it to my lookup table for the data warehouse. I need to generate a department ID for that. So for that purpose, we'll use a lookup, because a lookup table will always have less number of records, so we can go for a lookup. We have gone for a join here because the dimension table will have a lot of records. So in that case, we go for a join when the reference data set has a large number of records. So now in the lookup, it will be a simple lookup based on the department name column. We just need to do a lookup based on a department name column and then extract the department ID. So this is my column department. I just need to do a lookup. So I'll define the key here. And this is a normal lookup. And based on my requirements, whether I want to collect the reject record if I did not find a matching lookup value, or I just want to continue the run, I can select my options from here. So when a lookup failure happens, for now we'll just say continue if a lookup failure happens. Again, we want all the data to come from here. We can remove the department because we no longer need the department column because we have pulled its department ID. So we now want the department ID column from here. Since we have defined the mode as continue, it will also act as a left outer join. So all the records will be propagated to the output link of the lookup stage, irrespective of whether they found a match for the department name in the department ID table or not. So if the department ID table is also a dimension table, in a data warehouse, it will be defined as a dimension table. So for these scenarios, there would be a dummy record in the dimension table, a -1 record. So if there's any non-matching record, we can set the values to -1. I've done a basic lookup. I have pulled my department ID. I have pulled the employee ID for the already existing employee number record. Next, I want to apply some logic to derive the start date and the end date of my records. So that logic can be derived to write an if then else kind of condition. I need to use the transformer. There is no other way, no other processing stage that can be used. So again, we'll pull a transformer. And we'll connect it to the output from the lookup stage and take an output link out of the transformer. Now in the transformer, we'll just define the logic for deriving the start date, what should be the start date of this record and what should be the end date of this record in the dimension table. So again, I need all these columns that are coming in from my source. So I can just drag and drop them to the output link. Now I need two more columns. So I can create those columns. I need the start date and I need the end date. And the data type would be date. So mostly it will be timestamp. For this example, we'll take it as date. So now what should be the start date of these new records that I'm getting for the incremental source load? The start date can be the transaction load date. So it will be defined in the business rules basically how you should define your start date. But for our case, we have two dates. We have the hire date and the transaction date. So we'll define it as if it's a totally new record for that employee number that is coming in, then we'll take the hire date as a start date. So no previous record existed for that employee ever. So it's a totally new employee record. And if the employee number already existed, there was a previous record for the same employee, then we'll take the transaction date as the start date for that record. So we'll put a simple condition here. We'll use the if then else. If is null. And how can I check whether the employee number already existed in the dimension table or not? We have already done a join with the dimension table and we pulled the column employee ID. So for all the non-matching records, it would have been null. So I can check for the null value in the employee ID. If the employee ID is null, so it will be null in the case when it's a new employee record that is coming in, a new employee number that record that is coming in from the source. So if that is the case, I want to put my hire date as the start date. I can just right click and select my input column. Else, so there's just one else, so we do not need to put any more condition, else the transaction date. So that becomes my start date. Now what should be my end date? My end date, so I'll treat all the records that are coming in from the source as the latest records for those employee numbers. So when they are latest records in a dimension table, they are identified by the end date as being the maximum end date. So now we need to put the maximum end date here. Now end date is a date column. We already know what should be the end date value. It should be something like 9999/12/31 or 31 December 9999. So if I just put like this, so this we'll not be able to pass this value to the end date column because what we have put here is within quotes. That means it's a string value. So in a date data type, it would not be accepting a string value. So what we need to do now is use a type conversion function. So again, we can right click, we can go to function, we can check if there is a suitable type conversion function. So what we need to do is convert the string value that we are passing to a date data type. So there should be some function called string to date. So we have a function called string to date. This we can use. So there would be a type conversion, a proper type conversion would be done. So if there's a valid value coming in from the source, then I can convert it into a date data type. Now, since I'm hard coding, I know that I'm passing a valid value. Therefore, I'm not checking whether it's a valid value coming from the source in the form of a string. So I'll just say string to date. And we can give the date string here, which will be our input column. We can define the format as well in which the input string is coming. So this is the default format. So I do not need to specify the format. I just need to pass this value here. So I've just done the type conversion, and this should be parameterized. This should not be hard coded. We are just coding it for the sake of this example, but whenever we're designing a job, all these values which we are hard coding should always be passed by job parameters, by creating job parameters, and never hard coded in the job. So now we have defined the logic on how to drive the start date and the end date. Now we actually need to identify that which records which are coming from the source are the new records, that means new inserts altogether. Which records that are coming from the source are updates on the already existing data in the dimension table. And we can also identify if they are just copies of the record. So I have a record in the dimension table. I get a new record coming in from my source with the same attributes. So there is no change in the attribute, but I still have got it from my source. And that condition, that scenario is also possible because in the source database, they'll have a lot of columns. and we'll be using only a certain amount of columns from those all the existing columns in the source database. So for their scenario, probably they updated some field that is not relevant to us. Therefore, they created a new record in their source system. But the attributes that we are interested in have not got updated. So it will be a copy record for us. In that case, we do not need to do anything. So the stage that can do this, that can identify, compare the data in the two data sets, which is the dimension data, already existing data, and the new data that we are getting from the source, is another processing stage called the change capture stage. So this is the stage we are going to use today. And there are many other stages which can be used for implementing the slowly changing dimension. But this is a useful stage. And this is the most common design that I'm sharing. This is used in most of the production projects. You'll see the same design being followed. So this is a change capture stage. We'll just pull out the output link from this. Change capture stage requires two input links, a previous data set and a current data set. So it will compare between the previous data set and the current data set. So the previous data set for us is the already existing data in the dimension table. So this is the previous data set for us. And the current data set is the data that is flowing all the way till this change capture stage. That is coming from the source. Incremental data is the current data. So now we need to create a link from the sequential file stage to this change capture stage as well. And we have just directly joined this over here. So what we need to do is, we need to take this out. We need to connect this to a copy stage so that we can copy the same data across multiple output links. So we need to check the copy stage. Here we have the copy stage. And one output link will come here. Another output link will go as an input to the change capture stage. Now in the copy stage, I need to define my output mapping. So this is GS link 25, this is 26. So for the 25 link, I just need my employee number column and I need the employee ID column. So I will not map the other columns because they are not needed. For the link that is going to the change capture stage, I need all these columns which I'm going to compare. I don't need the employee ID, so I'll just remove it. So now we have the copy state. Simply it is copying data across multiple output links. So the same data from the dimension can be used across multiple stages. So again, we need to go back to the join stage and define the partitioning on this link on the employee number column, the key column on which we are going to perform the join. So now if we go and take a look at the change capture stage, and if we double click over here, it is all these properties. It is asking for the change keys. So the change key, the key column based on which we are comparing the data. So this would be your business key. So based on this key column value, we are trying to identify whether it's a new input record, whether it's a copied input record, whether it's an update input record or a deleted input record. So it will compare for the same business keys and try to identify whether some attribute value was changed or not. So the key for us here is the employee number column because that is a business key. So whatever is the business key of the dimension, that has to be used here. Again, it's a repeatable property. So if there are multiple keys on the table that define a unique record in the dimension, we can repeat this property. And the options are the same. The sort order, we can define the order in which we want to perform the sort, and the case sensitivity and the null position for the sorting. Now the next property is the change values. So it will compare, it will sort and partition all the records for the same employee number, and it will compare the attribute values for those records which exist for the same key value of the employee number. So we can define explicitly what are the columns that we want to compare the data on. So probably in a dimension, in a real-time scenario, you'll have many other columns which will be like audit columns. We do not want to compare the values of those columns. And there might be some columns in the dimension which we have defined as type 1 column. So we do not need to compare the values for those columns. We want to compare only values for certain columns. So I can go and specify my values here. It will give me a list of all the input columns which I want to compare. So I want to compare the band that might change, and the other column we want to put a compare on is the department ID that might have changed. So I can define the attributes on which I want to perform this check to identify whether it's a new record, updated, deleted, or whatever. Then the options, the change mode, explicit keys and values. When we say explicit keys and values, then we need to define the attributes. Otherwise, it will check all the columns which are coming in from the two input data sources by default. So to save processing time, we'll always define the columns on which we want to perform the check, because we'll never want to perform a check on all the columns that are coming from the source. So the change mode, we can keep it as explicit keys and values. Drop output for copy. So this basically means, so if it's a copy record, that means we have got two records for the same employee number, one from the previous link, one from the current link, and none of the attribute values as defined in this change values options has changed. That means it's a copy record. So do we want to take that record to the output? So we do not want that record to be taken in the output, because we don't have any action to be performed for that record. We can just drop that record, because if it's a copy record, none of the attribute values have changed, and I want to retain the record that I have in the dimension table. I do not need to update that record. So we can set it to true. If for any other reason I want that record, I want to identify that how many records came and the values did not change, then this can be set to false. So that record will be propagated to the output and it will not be dropped. If we set this to true, that record will simply be dropped. This is simply drop output for delete. So basically it tries to identify. So this is mostly will not be needed anytime when we're doing SCD. This simply means that any record that comes in from the source that existed in the previous data set, that is the dimension for us, and did not come in from the source, that will be treated as a record that is no longer valid and should be deleted from the dimension table. So that is not the scenario. All the records for all the business keys will not be coming in daily, only the updated records will be coming in. So we do not want to identify the delete records. So again, we'll set this to false, we can set it to, we can set it to true, it does not matter, because we'll not be identifying these kind of records. So we'll set it to false, because if we set it to true, then it will actually drop the record that we do not want. Then drop output for edit. Edit is the updated record. So any record that existed for the same employee number in the previous data set now has come in as a new record in my current data set, but with updated attribute values that will be identified as an edit record. So do I want to drop output for the edit record? I do not want to drop the output, so I'll set it to false. Drop output for insert. Insert is basically the new records. So new employee number records coming in which never existed in the dimension table will be identified as inserts through this stage. So we do not want to drop those records. We want to take them to the output. So we'll leave this as false. Now, if I go to the output, and this is also key-based comparison that is happening. So one thing, whenever we are performing any key-based operation, the thing that we need to remember always is that we need to partition and sort the data that is coming from the input link. And the partitioning that we need to go for is the hash partitioning, because it is a key-based partitioning. It just groups together all the records belonging to the same key value in the same partition. So employee number is what I'm performing my comparison on. So I'll do this, and we have to be careful to do it on both the input links and not skip the other one. Form sort. on the employee number column. Then we'll go to the output tab. The output tab will show us all the records, all the columns that are available from the input link. From my left input link, that is the current input link. So I want all the records which are coming in from my current input link. So I can just drag and drop. Now if we look here, we'll see that it has all the columns that are coming in from my current input link. It also has an additional column, generated column, which is known as the change code. Now this basically is the column that will contain the value to identify whether it's a new record, whether it's an edited record, copied record, or a deleted record. So based on the values that come in for this change code. So there are values, specific values defined that we need to remember when we are developing the code. If the change code value is 1, that means it's an insert record. That means it's a new record. If the change code value is 3, that means it's an update record or an edit record in terms of the change capture. So that's an update record. So we need to understand what these values mean, and there are two other values, 0 and 2, which would mean the copy records and the delete records. But we're not interested in those records. The records that we are concerned with are the new records that need to be inserted into the dimension table and the records which have been updated. So which are the update records and which are the new records. So based on the value that we get in this change code column, we can identify those records. So we'll again say OK. And that is the output that we'll be getting from this stage. Now the next thing that we want to do is to identify the update records and to identify the insert records. So always when we are updating a dimension table, we do not just simply go and add a database stage here and define the action as upsert. It's always advisable to split the output into two distinct links, one for the update records and one for the insert records. The update records, whatever is the data in the update record, based on that data, first the update will be done in the table and then the insert records will be inserted in the table. So it's never advised to do it as an upsert operation. It's always better to separate out the update records from the insert records and then first perform the update at the database level and then the insert operation. So now again, to identify the update and insert records, so I can identify based on the change code value. So I can use a filter if I want. I can just specify the where change code equal to 1 or 3, whatever values I want to check. But I also need to update the or end date the record, the history records. So I need to perform some additional logic. So I'll not go for a filter. I again need to go for a transformer because I'll be specifying some additional logic as well. So again, I'll pull a transformer. And now I'll take out two output links from the transformer. One will be the update records, the records that need to be updated in the dimension table. And the other link would be the insert records, the records which will be inserted as new records in the dimension table. Now technically, if we look at the dimension table, so update record as identified with the change capture stage is a record that is coming in from my source and that was already existing in my dimension table. That is my update record. And the insert record or the edit record is the one that is a new record for the new employee number that never existed in the dimension table. But technically speaking, what I want to update in the dimension table for type 2 is, so if this is our example, then the records that I'll be updating will be the already existing record. So the update that I want to make is update the end date of the latest record that already existed for that employee number in the dimension table. So the update operation is limited to end dating the already existing dimension record. Those will be my update records that will actually be technically updated in the database table. All the other records, whether identified as update records or insert records by the change capture state, are actually inserts. Technically, they are inserts for me in the dimension table. because even if it's an update record, I need to insert a new record with the new values. And if it is a new record altogether for the new employee number, then in any case, I need to insert that record. So based on that, what we'll be technically doing, we need to split the output records. So for the first link, let's identify the update records. So now I have two links. I don't need the stage variables. The first link is the update record. So what are attributes or what all information do I need to make that update? I'm updating an already existing record. The best way to update a record is to identify the key of that record which needs to be updated. And we have already identified that surrogate key in the first join that we performed with the dimension table. So we have already pulled out the employee ID from there. So that is the only information I need. Okay, so I have not pulled the employee ID column, so we need to pull the employee ID column till the output. We have the employee ID column here. We have the employee ID column here as well. So in the link ordering, we have the DS link 19. Okay, so again, if we go back to the change capture stage, we have to be careful of one thing. We have to define the link ordering that will help identify the before and the after records. Now, in this, if we look at this, the before record is identified as the DS link 19, the after record is the DS link 26. Whereas in our case, the DS link 26 should be the before record because that is the data from the dimension. So I need to take this up and make it as a before record. And then I'll have all the columns from my current link or the after record that I can map to the output. So we didn't have the employee ID column because we had not taken it from the dimension table and we had defined the dimension table as the after data set. So whenever we do this, we have to be careful to define the link ordering in the correct way. So now we have all the records which came from the current link, that is the incremental data records and the change code as well. So now if we go back to the transformer and define the data that we require for the update link. So what I require now is the employee ID based on which I'll identify the already existing record in the dimension table. So this is to identify the record, the key based on which I'll be updating the record. And the attribute that we need to update is the end date attribute. So whatever is the end date that already exists in my dimension table. Now all these records and all this data that we are getting, it is coming from my current link. For the current link, I have defined the end date as the maximum end date. So that is not what I want to update. I want to define the end date of the already existing dimension record as the start date of the new record that I'll be inserting. So what I need to do here is simply map the start date to this end date. So for the record that already exists in the dimension table, it would be end dated. That means its end date would be put as the start date of the next record, which would now become the current record. And for the other link in which we want to insert the records, we need all these columns for that other link because all the attributes will be inserted. Now we don't have the transaction date in a dimension table, so we can just delete the unwanted columns. We need the start date, end date, department ID, band, hire date, first name, last name, and employee number. And I don't need the change code because that is the one that I'll use to define the constraint to identify whether it's an update record or a insert record. Also, I do not need this employee ID value because now I'm inserting new records. When I'm inserting new records, that means I need to generate a new surrogate ID value because every record in the dimension table should have a distinct surrogate key value. So I do not need this employee ID record. I will need to generate it. So now we've defined the columns and how they'll be updated or inserted in the table. The next thing that we need to do is define the constraint. So constraint is whatever is the output that we have got from the change capture stage. That output, the results are captured in the attribute change code. So again, go to the input column, select the change code, and the change code for update records would be 3. So that's already defined. It never changes. These are defined values. The change code generated by the change capture stage for the update records will always be 3. For the insert records, it will be 1. So now we want again change code should be 1. So whatever are the new records that need to be inserted. Also the records that have been identified as update records in the change capture stage, they need to be inserted as new records as well. So in this link, I need records, all the records which have the change code either defined as 1 or 3. So I'll combine all those conditions in this link. So basically I have all the records flowing down the insert link, and I have all the records which are identified as update records going to the update link, where what will be happening is simply the existing dimension record will be end dated by the update action. So now I have these two output links. The only thing I need to do is connect them to a data set, and this data set will then be used to update the actual dimension table. And another data set for the insert records. Now for the insert records, the one thing that still remains to be done is to generate that ID, the surrogate key value for the employee ID column. So to do that, again, the ways to do it, either it can be done on a database level. So that will all be managed by the database. The ID columns most of the times are not defined as identity columns on the database level. The control is left to the application. So mostly in Datastage itself, job itself, we need to generate the surrogate ID. So for that, again, we need to go to the processing category. There's a stage that can do this, and that is the surrogate key generator stage. So again, we'll just attach this here. And connect it to the output data set. Now what values need to be defined here is basically the same. The option is also there in the transformer, but since we have multiple output links coming out, we do not want to define it in transformer. And if we define it explicitly, it's more visible on the job, so we know what the job is exactly doing. So we'll define it through a surrogate key generator stage. The basic properties that we need to fill, what will be the output column name. So the output column name should be the same as a surrogate ID column in the table. So this is my employee ID. Now what is my source type? Source type can be a flat file or a database sequence. So again, if you give database sequence, the controls will be in the hands of the database. So most of the times, the control should be in the hands of Datastage. So we'll define a flat file. We'll not go for database sequence. So the only problem with the database sequence is that it has to be managed at the database level. The flat file is totally something that Datastage is responsible for. So we'll define the source type as flat file. Then it asks us for the name of the source file. So again, the same way, the same convention you have to follow. You have to give the path name and the file name. Now file name would be something like test_sk.sk or .sk. So any extension can be given. Just to make it easy to identify, we'll give either sk or sk to identify that it's a surrogate key file. So this is the path, this is the file name. Now how do we generate this file? So you can either go to the Unix itself on the server, just type a touch command and generate an empty file and give it all the permissions so that all the user IDs that are used to run the Datastage job have permissions on this file. So we can simply touch it and generate the surrogate key file. This stage in itself can also be used to generate the surrogate key file. When you use this stage, you'll have the options to define what should be the initial value of that file, and all these different options we'll get. So even through the surrogate key generator, when we have already touched the file in the Unix server, we can define what should be the initial value. So that would be the initial value that would be given to the first surrogate ID that is generated through this file. So basically what this does is same as we discussed for the transformer. There is a file that is maintained at the Unix level. We can put it into any directory that we want. So there's just a file. The first time the job runs, a set of distinct unique ID values is generated by the surrogate key generator stage. And that information is stored in this file. The next time we run the same Datastage job, it will generate another set of unique values. So there will never be any overlapping values irrespective of how many Datastage job runs we perform. So that is the use of the surrogate key generator stage to this makes sure that the ID values that are generated are always unique values. Now it limits itself to generating unique values. It does not generate the values sequentially. It does not guarantee a sequential generation of the ID values. So it just generates the unique ID values. If we still want to forcefully generate unique ID value, sequential ID values, then we have to set all these parameters like the file block size, and if we set it to user defined, then we can define the block size. But this is not advisable because block size every time, if we set this to 1, then it will generate sequential IDs, but the IO processing time will be increased. So it generates one ID, then stores it on the system, then generates another site ID and stores it on the system. This is how it will work at the back end. So again, it's not advisable and it's not needed as well. We just want a set of unique values. We are not concerned about getting a sequential ID value because it's a surrogate key in the dimension table. Then another option that is available here is generate key from the last highest value. So again, if we say yes to this, what will happen is because it does not generate in a sequential order, it just generates some blocks in some blocks. So there are gaps between the keys that are generated. So the next time the job is run and we have set this to 1, then it will start from the highest value. So that gap will always be there. Otherwise, what will happen is next time we run the job, it might pick any value that existed within that gap as well. So we can set it to no, it all depends on the project requirement, but in a practical data warehouse, we'll never be concerned about a sequential surrogate key ID being generated or there being gaps or no gaps. We'll not be concerned with these things, so we can just leave all these parameters to the default values. Then we have all the surrogate ID coming in, and we don't need to define a key because it's not a key-based operation. It will just generate it for every column every input record that comes to this stage. Then in the output, we'll get whatever column name we have defined will be there for us to propagate to the output, and a default derivation will be shown, that is surrogate key generator employee ID. So that can simply be mapped to the output. and we have our data sets connected. So this link now will have all the insert records, all the records that will be inserted technically into the database table, and the surrogate ID that will be associated with those records. This will have all the records which already existed in the dimension. So the same surrogate ID value and the update attribute is only the end date attribute. So those records need to be end dated in the table, so the end date will be updated. This is basically the simple job design that will be followed for a slowly changing dimension. This is the most commonly used job design for SCD2 implementations in Datastage. So another thing that we need to remember here is if we go to the job properties, so whenever we are performing any kinds of operations wherein we are joining data from coming from two or more input links, we should take care to not enable this runtime column propagation. So we should have disabled it in the beginning itself so that whenever we added a new stage, by default this would not have been enabled. Now if we go and look at the stages, we'll see. Okay, so it gave us an option that for all the existing links also it will be disabled. So we can check it. Because if it is enabled and the same column name is coming from two different output links, it will randomly pick one column from any of the output links, drop the other column, and it might result in incorrect results. So this property is always visible in the outputs tab of the stage. So you can go to the outputs tab, you'll see that there is this thing, runtime column propagation. If we don't disable it at the job level, then by default it will be checked. And we do not want that, so we'll just uncheck it. So this property is mostly only needed in case when we are not defining the column metadata explicitly, we are using a schema file and we are just propagating the data the entire way. So to be able to run this job, we need to define the dataset names. And for the other, we can just define as an insert dataset. So a dataset always and always should have an extension of .ds because it's not like a text file. It's an operating system file. So this is a job design that will be followed. We'll compile and try to run this job. Any questions on the job design?
Nope.
Okay. So if there is any compilation error, we can either do a show error and it will highlight the stage on which the error is encountered. So this is a join stage, it's showing the error. So just close, go to that stage. And because we we added a copy stage later, so it's not showing the correct link name, so we can just remap this. So as we saw yesterday in the session, every time we are compiling the job, once it compiles successfully, an executable will be created. That will be in the OSH language. And then that executable will be run at runtime when we run it, giving the suitable job parameters. That executable will be executed at the backend through Datastage server. So this is one stage that can perform the type 2 implementation. There is an SCD stage as well. So we'll see that tomorrow. So whenever it is showing the links as blue, that means the processing is happening. Whenever it's showing as green, that means it has completed. So everything is in green, that means that the processing has been completed and the job has finished fine. And if we look here, then we have 15 records coming out from the change capture stage, but we wanted only the 8 records to come out of the change capture stage, and the 15 records are coming out because we did not set the option to drop the records identified as delete records. So that's why all the records from the dimension as well, which have not come in today in our incremental load, have been passed as an output from the change capture stage. So we can just go back here and drop those records. But since even if they are delete records and they have been passed to the output of the change capture stage, they'll have another change code. So the change code for delete records would be 2. So 2 would be the change code for the delete records. And we have put our constraints based on the change code. So that's why they have not been propagated here. So the 4 records which are identified as update records and 6 records which are identified as the new records that need to be inserted. And that is okay. So we have 6 records as identified as insert records, out of which 4 records will be, technically speaking, the records uh, for which the dimension records already existed and they were identified as update records. 2 records are there which are entirely new employee number records that are getting inserted into the dimension table. So this is basically 2 new records and 4 updated records, and these are the 4 records which will be end dated in the dimension table. So once we have collected them into separate data sets, the only other thing that we need to do is there can be a common job that can be built for updating the dimension table, or we can build another job as a second step of this job, and we'll use these data set values to first update the dimension table, and then we'll insert the dimension table, insert the records in the dimension table. So first we need to update and then we'll perform the insert operation in the dimension table. So that is how we can implement the SCD2 using the change capture stage. This is again the most common job design for the SCD Type 2. We'll also look at some other job designs which are possible for the SCD Type 2 implementation. So we'll look at it tomorrow. So any